Welcome. Why don't we get started? Good afternoon. Welcome to our Dean's Lecture. This is the 10th one now in a series. I can't believe it's been a decade since we started this tradition in the School of Engineering. My name is Kyung-Bum Lee. I'm the Dean of Engineering, Carroll Family Professor, and Professor of Chemical and Biological Engineering at Tufts. I'm going to be your host today, although I'll be sharing the duties with my colleague, Chris Swan, Dean of Undergraduate Education. We'll be monitoring the questions and answers. We're going to ask for a few housekeeping items before we get started and say a few things about our speaker. Please keep your cell phones off if you don't mind, just to make sure that we don't have interruptions. We'll also be recording the lecture by our speaker today so that we can share it over digital media at some point in the future. Just want to let you know that's what's going to take place. So each year, I'm pleased to welcome exceptional guest speakers to our campus to educate the Tufts community on the important work of engineers out in society and a wide range of topics, from business to education to public service, and highlight really the relevance of engineering in terms of its impact on society, on the many challenges we face in today's world, in the future as well. So over the years, we've had a chance to welcome 9, we have a 10th one today here today, amazing speakers to campus to give the Dean's Lecture, all trailblazers and leaders in their fields. The ranks have included inventors, entrepreneurs, vice presidents, CEOs, and lastly, even an astronaut last year. The talks covered a wide range of topics from engineering education to 3D printing, human organ regeneration, space exploration, and as you hear today, mining and education. So our 10th speaker, Eduardo Hochschild, is also a jumbo. So it's a special pleasure for me to welcome him back to campus and introduce him as well. We are also honored to have Dr. Tony Monaco, our president of the university, who will say a few things about Eduardo in his remarks. Thank you, Tony, for being here.
Well, thank you, Dean Lean. Good afternoon, everyone. It's a pleasure to come back. I look forward to this event every year for the 10th annual School of Engineering Dean's Lecture. I look forward to it because it is a special lecture, and that means we get really excellent speakers with interesting topics every year. Today, I'm pleased to welcome our guest speaker, Eduardo Hochschild, chairman of the Hochschild Mining Group and esteemed Tufts School of Engineering alumnus. Company leaders must strike the right balance between leadership and stewardship. As the chairman of the Hochschild Mining Group, Mr. Hochschild has prioritized engineering the cleanest mines possible, including a new project focused on critical rare earth materials. He graduated from Tufts in 1987 with a BS in engineering physics. I understand this is a very elite group. He had 3 in his graduating class. It's so elite, I've been here for 12 years and I didn't even know it existed. I understand we now have 4 in the graduating class, so we've expanded access to this elite program. But as you can see, being an expert in 2 of the toughest subjects we offer does have special skills. After graduation, he joined the Hochschild Mining Group, a Peru-based mining and industrial group, as a safety assistant in the Arcata unit. In 2006, he was appointed chairman, and he also is chairman of several other organizations, including the University of Engineering and Technology in Peru, called UTEC, the Museum of Contemporary Art in Lima, and Peruvian cement company Cementos Pacasmayo. Please join me in giving Dr. Eduardo Hochschild a jumbo welcome back to campus. Thank you.
My colleagues in here with some physics. Thank you very much. Thank you very much, President Tony Monaco. Thank you very much, Dean Lee and Dean Swan. Thank you to all of you, and thank you very much, Carlos, for accompanying me. Carlos is the CEO of the university that I started some years ago. I want to tell you a little bit about about me. Sorry, it might be boring. I know you had an astronaut here, so that must have been a little bit more interesting. But then bear with me, I'm talking about something different to you. Something different, which is Hochschule Mining, Aclare, which might be a little bit more interesting to you, and of course UTech that you know is a university. I'll tell a little bit about the story of the family because that's what Tony asked me. The family started in 1911 with Mauricio Hochschul starting operations in South America in Bolivia. By the 1930s, Mauricio realized that there were problems going on in Germany, of course. He was a Jew at that time. The family was Jewish at that time. Now we are, most of us, Catholic, but that's just because things happened and evolved. And Mauricio decided to help Jews. And he bought visas in Bolivia for about 20,000 Jews, who he took all the way from Germany to Bolivia. In the 1930s, he joined also with a German university and developed a new system to work tin with low-grade tin. And he managed to become the world's largest producer of tin, which made obviously a lot of money to be able to buy the visas to get people out of Germany back in those times. Things in Latin America get complicated, and by 1957, he got nationalized. But he was a big entrepreneur, a person that actually led the family, and started a mine in Chile called Mantos Blancos. What is so different to Mantos Blancos? It has a complete water system of recovery. It's in the middle of the desert, so water was very difficult, very scarce, so he managed actually to recover most of it, which is something that nowadays is compulsory in the mining industry. Well, he did it 60 years ago. So that is something that was pretty unique to him, and he managed to do that in mine. Of course, he passed away, and by 1998, when my father passed away, I took over. By the way, when I graduated from Tufts, I called my father, said, I want to work with you. Okay, then if you come work with me, holidays are over. Now come study with me. And he sent me out to the mines. What happened up in the mines? I learned my way through the mines, actually at 4,700 meters above sea level, so that was pretty bare land, as you can see. It's not a single tree around there. Of course, animals are not there. We are there. We human beings are there to produce. We are, well, that's what we are doing now, not back then. That's how much we produce. But more interesting than this slide, which is, of course, something that we used to sell to the stockholders. The company is quoted in London, so we have 62% of the shareholders being held in London, 38% held by the family still. This is something we show who we are. We are in Peru, Argentina, Chile, and Brazil. As you can see, South America for sure, and a project in Canada. But this is more interesting, what we aim for. We aim to be environmentally very clean, or as clean as we can. So what we have is an underground mine. So we backfill most of the tailings after cleaning them. So we take only what we want and put it back there what we don't want. So we just put backfill the tailings inside. Not all of it, of course, but a substantial percentage of it. People are the people that we work with. We have 35% of the workforce from local communities. Why not more? Because there are not more people in the local communities. As you see, it's a pretty barren land. Not that many people around. That does not mean we don't have problems with the communities, because there are communities that don't like us, somebody that is, of course, not our best friend. But we try to help them as much as we can. As you can see in the last slide, which says community, we've given to communities in 2022 directly of over $6 million, and indirectly through the government, close to $8 million. By the way, that adds up to, since we all know, and if not, we can use a calculator, over $14 million. The shareholders have taken that year $20 million. So we share with the community a lot. But that's never enough. And there was a question on that. That's why I want to answer it straight out. It's complicated because I lived up there. I partied with them. I knew them. I had a life up there for a couple of years because my father sent me up there for a couple of years. Got friends up there, but there's always that shining path, which you've always heard of, which is back in the violent, you know that. And then sometimes it comes around and it just moves the people, and you have that violence in friends that were your friends, And when the shining path leaves, because we managed to get it to leave, then we sit down again and negotiate. And talk, because we always negotiate. There's always a community, there's always a neighbor, there's always somebody who wants something different. But the best thing is to listen to them. We won't do everything you want, and we won't do everything you want. So it's a matter of sitting down and talking. And in the past 111 years, we've managed to come to the right conclusion. There was a project we had in Mexico we didn't go through. Why? Because we didn't find enough reserves, by the way, so we didn't develop it. We did develop another one in the middle of a very complicated region, and when it got depleted, we just left, because that's what happens with the mining. When it's depleted, you leave. You leave in the best environmental way, but you leave. When there's no more ore, you don't continue. But I don't want to specify on this mining. I would like to go to the other mining, which is a lot more interesting for you guys, and for me too, which is this. This is, I don't know if you've heard of rare earths. You've always heard of electric cars, of course. Well, electric cars would not work without dysprosium. And dysprosium is only produced right now in China. There's no other mine in the world that's producing dysprosium. It's a mine that's starting production next month in Brazil, and 100% of its production has been already bought for the next 10 years by the Chinese. So if you want to make electric cars in the States, we have to start looking at dysprosium that can be actually managed and worked in the States. So we found some in the Penco region, which is southern Chile. Some people say they have found rare earth deposits in in Sweden, in Iceland. The thing about the rare earths is that they're not as rare as you can imagine, but the rare earths are associated with the granite. And the rare earths, you have thorium, and the thorium is highly radioactive, the same as uranium. And all of them are in the granite. For some strange reason, which I do not know, and maybe you can find out, but they call it weathering, the ions in the granite just escape, and they go into what you call it ionic clays. With one very, very nice thing is that the thorium is too heavy to leave, so the thorium stays in the granite. So if you touch the clays, nothing happens to you. It's not radioactive. You can actually work with them. So you take the clays out, you clean them, and you can put them back in, because they have absolutely no radioactivity, and you have to manage to have no chemicals involved in the game. And we've managed that. Actually, as a matter of fact, tomorrow we have our board is going to be at MIT, because MIT is helping us make the cleanest mine possible. We recycle over 90% of water. We recycle over 90% of all chemicals. We do not use explosives, and we put the tailings back where they were. So as a cleaner mine, that is what I would call the new mining system. Unfortunately, that cannot be done with copper, not yet. Gold or silver, I don't know. But we can do it with rare earths, and we're trying to do it. And that is, to me, a very interesting future. Now, that is an iconic mine that will enter production in the next 2 years. We're still working with the communities, working with the licenses, working with the Chilean government, and it will enter production in the next couple of years. What happens is, like, you take 20 to 30 meters and don't touch more, because then you get to the granite, just with a payloader. And the front loader, you do not touch any explosive. Put in the truck, put in the tanks with phosphoric acid. Anybody who's done some gardening knows that phosphoric acid is good for the plants. Too much is too bad for the plants, so we just put enough to get what we want out, and then we clean it, and we send the clays back to where they were. So that is a perfect mine in a perfect environment. The water we will be using, because we're not using it yet, will be the sewer from the town. So we're actually using even their own water. That is what I consider to be the big change in mining. Somebody asked us a question, what has happened? What differences have been in the past 30 years since I graduated from college? 36 years, as a matter of fact. That, a different type of mining. And that is coming. Unfortunately, it's not in production yet, but of course, finding the deposit, finding the license, explaining to the government what it is, that it does not have radioactivity, is interesting. And then putting in production will be done in the next couple of years. no use of explosive, no crushing, no milling, so no major energy. No tailings dam because you put the clays back where they were. We recycle. We use 100% of recycled water, and then we recycle 95% of the water we use, and 99% of the reagents. I don't know why they didn't put 100%, but it's pretty much close to it. No radioactivity. And what we're trying to do is, when we put the clay back, we can revegetate with local and native species. So that is something that will revolutionize an industry, which is the mining industry. What is dysprosium good for? By the way, you cannot make a windmill without it. You cannot make an electric car without it. Why? Because that's part of what you use for the magnets, which are necessary for the motors in both the car and the turbine. The world will need 4,000 tons of dysprosium by 2030 if it wants to increase its energy related to electric cars. Right now, the Western world produces exactly 0. So there's a lot of leeway to continue, not only us, but other people who want to enter the market. How much will we produce in the first module? 50 tons. Out of 4,000, there's space for more. We believe we will be able to increase that substantially. But of course, 4,000 tons is a lot of tons to be produced. But we need it. And whoever thinks that we can move into the future without looking at that is impossible. Everybody here has something metal related. May that be a cell phone, which I'm pretty sure everybody does, a watch, a belt. Even your shirt needed to be ironed. And iron is, of course, a metal. So everything, the whole world depends on mines. We just need to make the mines reasonably better, and that's a way to do it. The other company which I'm related to, which is also pretty interesting for you guys, is Pacasmayo. Pacasmayo is a cement company. Oh yeah, that's the biggest creator of CO2 in the world, cement company. Yes, probably cement and cows, by the way. Somewhere around there, I don't know which one is worse. But look what we've done. We've managed to reduce from 95% of CO2 emissions in 1980s to 66. So it is possible to reduce it. It is possible to do it. We just have to have the will to do it. The only thing with the cement, and that's the main problem with it, is that I can make a cement with zero CO2. It's going to cost 3,000 tons per ton. People need to build their houses. I mean, we're not in the States, we're in Peru. Here in the States, probably the cement for this building accounted for probably 10% of the cost. I'm not sure, but something like that. You don't even know. I mean, that's how important cement was for you in the building of this infrastructure, where probably everything else was more important. In a house, for somebody in Peru, cement is 90% of the cost. So if you make it more expensive, they cannot buy it. So you have to be efficient in environment and in cost. So you cannot go over $100 per ton and make sure that that cement will last for at least 100 years. Probably nobody in this room will be there in 100 years, so that's okay. They can buy it, you can buy it, and it will be there for your grandchildren. That's how much CO2 has been not produced due to what we've been doing. Of course, the cement had to be done, and people were going to build their houses. May we sell it or not? But by us doing that research, we've managed to reduce the amount of CO2 emitted by 2 million tons. That is a reality. So there are things that you can do in the old industries that are good for humanity. Don't look only at internet, artificial intelligence, and nice things that are very, very nice, very flashy. If you don't have this, people won't have a house, people won't have a car. You need that for the future. We need that for the future. You more than I, because as we were saying at lunch, our future is, as you said, not likely as long as, I don't know what nice word you use, but you have to start thinking that people in underdeveloped countries need the cement. So you cannot forbid them from construction. And you cannot develop cement that costs $3,000 per ton. What we need is to make the cement cleaner, cement better, cement with less CO2 contamination. We cannot make a world without mining. What we can make is a better mine. And that's something that I hope you understand when I'm saying that. If I take mining away from you, the building doesn't exist. If I take cement away from you, Tufts doesn't exist. So we need both of those things. We just have to make them better. And research is there. We can do it. We have been able to make cement with lower contamination, yes. We've managed to get to 60. Unfortunately, and we're talking to one of the professors today, the governments don't understand it. Governments want the bridge to last for 200 years, and they don't understand the cements are just as good. So we have to make them understand. But that's a different story. That's more of a legal side, but we need to do that. The cement can be better. We have added 66% clinker factor. We can do it better. We can get to 60. We can probably get to 50 eventually. Takes a lot of research because whoever wants a house wants it to last for 100 years. So I have to make sure that it lasts for 100 years. And research has got to be there to back it up. What do we have? USA, 90%. Europe, 77. We, 73. Why can't we reduce it to 66? Because due to the government. If not, we could be below 66. But we'll make it. That's our part. That's our responsibility. But the US government has got to help us. Because if the US understands what I'm saying and reduces its clinker cement, everybody in the world does it. The standards are set in the US for the whole world. That's why it's difficult for us to change on a US standard. What are we're trying to keep on reducing the clinker? By far. Yes, we try. We try every day. That's a major research. We have a major lab in the university doing that. And we will. We will make it better. What other initiative we have in the jungle? We decided 15 years ago, maybe even more than that, a fish was going into extinction. And we're in the jungle. The cement plant is in the northern part of Peru and in the jungle, which is what we're talking about during lunch. And this fish that you see there, which is the largest freshwater fish, it can weigh over 300 pounds probably, it was going to extinction. So we decided we wanted to save it. The government had probably about 20 or 30 in captivity, couldn't get them to reproduce, and decided to give half of them to the communities. When you give half of the fish you have to the community, you don't know which one is female and which one is male. You don't know what you give. So you just gave half of them. We bought the other half and sent them by first-class ticket to the cement plant in a private plane and put them in a lake, in a lagoon next to the cement plant, trying to figure out which one was male and which one's female. So we called the expert. That was even more interesting. We called the Peruvian expert on paicha. This is called the name of this paicha, as you can see it there. Tell us which one is male, which one is female. I said, give me a knife, okay? You cut it in half, and you close the door from the outside. It took us 2 years to figure out which one was a male and which one was female. They have a different, don't ask me, I'm not a biologist, but all that they told me was a different color that time when they can. Now, okay, at least they knew which one was male, which one was female. Try to make them couple. They wouldn't. They're very shy. They need their own space. Yeah, okay, some people are laughing, but hey, you have to nurture that. So we managed to reproduce them. Now the protocol, we managed to get the protocol for reproduction. It is in the web. Whoever wants it can access it. We wanted to give it to the Peruvian government. We decided not to because, quite frankly, we didn't trust the Peruvian government, so we just put the internet is safer. So if whoever wants it can have it. May that be Peruvian, Brazilian, or even Asian if they want, because some countries in Asia might have fish similar to this. But it is there. It is out of what World Wildlife Fund would call in extinction. I know it was being sold at Whole Foods. I don't know if it's still being sold there, but I mean, I'm in the cement and mining industry. Definitely the fishing industry is not my not my part of the industry. And that, anecdotes which are pretty funny, was when we started producing them, we started selling them because, I mean, they were produced. We managed to reproduce them. And I figured out I was not in the selling mode when somebody called me on a Sunday, lunch family time. Can you please send me 2 kilos of fish? I'm like, what? No, I'm not in the selling mode, so that was it. So now the communities can do that for us, and of course they will sell it and make money out of it. And if you go to Peru, you can eat it probably in most restaurants in Lima. It's a very nice white meat, and that's what it is. But as a family and as a company, we understand that there is responsibility towards the future. My kids understand it. I've got 4 of them. My eldest is right now working in the jungle. She's working in an NGO which is very much related to environment and the jungle. My son is entering the production side, in the mining side. And, well, those are the pictures of the lagoon and the paiches and wherever they are. And my daughter will enter the cream on top of, or the cherry on top of the ice cream, which is the university, actually my wife and I decided to create 10 years ago, as a matter of fact. We're having our 10th anniversary. I know Tufts is having its 60th, 70th, 100th anniversary? Okay. 150th anniversary, whatever. As is a 10th anniversary. But we're getting there. We're pushing it, and we're getting there. We decided to start, by the way, the CEO of the university is here, and the CEO of the mining side is here also. So Carlos Herring is here. So any question that I cannot answer, I'll ask them to help me. And any question that I cannot answer on the mining side, Ignacio will help me. But I'll try to answer as many as I can. There was a question on hydrogen. I've got no idea what we can do in hydrogen in the mines, but that is a different story. But what is the university? And that, I think, is something that we decided to build 10 years ago, as I said, and it's an engineering school, mostly. And it started in 2012, and now we're building the second tower, as I might say. We have 3,700 students, that's 3,700 students, in undergraduate programs, and we're starting the master's and PhD program. We have, as you see, 3,700 students, 100 graduates, 585 students, graduate, alumni. I don't know how many Tufts has, but I'm pretty sure a little bit more than 585. But then again, in 150 years, maybe we'll be competing. I don't know. But we'll have more than 1,400 students are under financial help. What does it mean? It's a non-for-profit. And I'm saying not non-for-profit. It costs a lot of money. But we've done it. It's working, and it's right there. It's helping people that are coming from the lowest part of society. It's amazing. I mean, we had a kid that actually, we have an exam, not the SAT, but I mean kind of an exam, had a very good grade. Hey, come work with us. Come study with us. No, I can't. Okay, we'll lend you the money. Don't worry. You pay somebody else when you graduate. No, I can't. Okay, we'll give you a scholarship. No, I can't. I'm like, what about having free education? Don't you understand? What about being the son of a raped woman? I don't have money for food. That is the kind of story we have. That guy graduated already, I guess. Or I don't know if he graduated, because I don't really want to know his name. But that is the stories we have, and quite a number of them. They come from all over Peru. Some have come from outside of Peru, it's true. But most will be from Peru, and as I say, all are welcome. And as it's non-for-profit, we have a lot of people under financial aid. 12 undergrad programs, 4 masters. We're just starting with the masters. Of course, no PhD yet. Projects, well, we have the largest patent per student in Peru, but that's nothing compared to, of course, what you're used to over here. Number 1 per capita publication. Why? Because we put a lot of emphasis in getting the best. And the best means that the building that we have won the RIBA Award of Architecture from London, and by the way, also the Pritzker Award, which I guess you both know. It's the only one that I know in South America that has won those awards. Why? Because we believe that if we were going to do things right, we're going to do it correctly. And that's what we did. We want innovation, for sure. Entrepreneurship, definitely. That's what we need in Peru. We need innovation. We need people to create things. Oh, I think that was too fast. Well, that's what we have, 9 engineer programs, 2 technological programs, and the campus. As I said, we won the RIBA award, but also the Pritzker. And now we're building the second tower, which will be done by the same architects, probably not as fancy as the first one because it was pretty expensive. We have these research centers, which I was talking to you guys this morning. One in Puerto Research Technology Center, that's in the jungle. 60% of Peruvian territory is the Amazon jungle. So you might as well take care of it. And we have a lot of research there. We have a lot to be done. We're starting. We saved the fish, so we know how to do it, but we have to do more than that. There's not only one fish in the jungle, there's a lot more than that. But we have to get back there and keep on going. And on the cement, as I said, we have a lot of research. The research of the cement company is in the university. Why? Because it does research better than the cement company, of course. Where else I can say that, Latin America. We'll eventually say the American continent, by the way. We'll include the US in what we're doing. And those are the universities we're allied with. We have alliances with. We have MIT, of course, Harvard, Purdue, and hopefully Tufts not too long in the future. What do we have with Duke? We have a 4+1, as well as with Purdue, and hopefully we can do that here too. What does it mean? Peru forces engineering students to have a 5-year program. The US is 4. So they study 4 years in Peru. They come to the States. The Duke University or Purdue University recognizes that the student is good because they apply like anybody else. They get accepted because they're good. If not, they don't come. I mean, that's pretty obvious. They finish the 5th year here, 6th, 7th year, whatever they want. But the 5th year here, they get the bachelor's in Peru and the master's in the States. So that is what we're looking for, and that allows the students. The university is not related to any of the companies. They do not study for the benefit of anybody but themselves and their families. Not to anybody else. They don't owe a favor to anybody. If they receive the scholarship, they owe it to the next generation, and that's something we force onto them. If you receive something, give it to your kid, your nephew, your niece, both of them if you want, but look to the next generation. Give back to somebody. Unfortunately, Peru does not have the concept of endowment that the US has. We need to force this into them. But they are understanding it. If you receive something, give it to somebody else. Doesn't matter who that person is. Choose, but do it. And that is where we're going. I think that I have said enough for now. I don't know if I've gone over time or not over time. There was another question, what research we have done. Just one. Well, that's the backfill that I was saying. Most of the tailings go back in. But that is something that we're trying to develop. We haven't gotten there yet. We will come back to it, but we got stuck at some point, and that is trying to make, and I was talking to you, I think, I don't know, no, to oil-related research, oil-related drilling. Well, that is mining, and try to mine, and probably artificial intelligence will be useful for that, with just a drill that goes and looks for stuff. Mining, copper, gold, whatever, is deeper and deeper. And it's more and more complicated. It's unsafe in some places. We can make it safe, but it's more and more complicated. That kind of engineering will eventually come, but it's not ready yet. We had a major problem here. In the articulate mechanism, they told me not to go through that, that's why I can't go there. But that mill, and make sure that the tension would not break the machine whilst it was trying to drill in a tension. So that's where we stopped because we couldn't keep on going. But we will come back to it, and we'll eventually be able to do things differently. I think that would cover our presentation, and hope that you understand that even those old industries have a lot to offer, and a lot of innovation to come, and a lot that can be done to help this. And if you don't have them, we don't have the future either. Thank you.
Okay, make sure this is working. Yes? Good, thank you. Well, I want to thank you for your really interesting and actually very honest presentation about mining and about the history of it as well. You did mention some of these questions, which is great. Of course, there are more questions that I can dig into. So I'm going to try to do that and be happy to hear what your thinking is on that. You mentioned community a lot, and you mentioned community responsibility, quote unquote, community responsibility. So I'd like to know a little bit more, a little more specifics about what you've done, or what you have done, actually, with, as your company, to engage with these communities with respect to what they understand as their pains, their issues that they are having, with the needs that they may have and the desires that they may have for the work that you're about to do.
Communities are a pretty large name. I need to focus on one or the other. We were entering a new area, a new mine, a new zone in Peru. I used to live in one, so I knew the communities around me and I would understand them. I knew the people, so that was not an issue. And if I had a problem, I would just call them, and they didn't have a cell phone 25 years ago, 30 years ago. I didn't have one either, so I would just have to go and see them. And actually, we'd just sit down and talk, and of course there were problems, but I mean, we'd sit down. We went to this new area, and we just couldn't get them to sit down. And like, okay, something is going on, because, I mean, it's not that different. So we sent a sociologist to tell you how difficult it is to talk one community to the other. And we did a research on them to understand them. We figured out that most of them, majority of them, were kids of the terrorism, parents, orphans of terrorists. So it's difficult conversation, difficult to engage with them, and a lot more difficult. So you have to go one by one. We've been there for 111 years. We have our issues, for sure we have. What they mainly want is jobs for us to train them. So we try to train them. But of course, for them to go all the way to an engineering degree, it's going to take a while, probably a generation. But they will have, that will happen. And we're trying to get there. The first jobs is more the basic ones. And we try to help them in whatever we can in that area. 35% are working already, so that's a lot. We need to get more? Yes, but then again you have the terrorism, which did hit a lot of us southern Peru. As I said, Peru is 1.5 times France. The northern part of Peru didn't have terrorists. The terrorists were in the south. The mine is in the south. So we have to deal with that, and that's a reality. So you have to learn which one is which, and oof, that's an everyday.
That's an everyday thing, and I'm curious about, is this something that you run into occasionally? Not every community that you're going to be entering into or connecting to, you have that sort of depth of having to do that interaction? Or is this something that you continuously do? In other words, it's part of your actual process of engaging with communities?
Anthony, do you engage with all your neighbors?
Yes.
Every day?
Well, not every day, but I mean, through the university.
Yeah, through the
yes.
university, yes.
Yeah,
Okay.
we just keep in touch with lots of programs.
Sorry for the question, but we're the same. We have to keep in touch.
No, it's a high priority.
And some days they wake up in a good mood, some days in a bad mood. And you have to always be clean of mind, and some days you have more of a problem than other days. But you have to be able to sit down every day with them and have a special team dedicated to that, to sitting with them. And here at Tufts and Medford, Somerville, there are people that probably went to school, that could sit down at the table, that probably can understand you when you sit down with people that are orphans of terrorism. It's a little bit more complicated, but we've been there for a while, but we'll have our issues and we'll have our problems for sure.
And a final final question on this regard, just in general, the general regard. The engagement that you do, you somehow have to explain to these communities or interact with these communities with respect to what are the benefits to them and all, basically how they also connect to the benefits that will be happening for Hoshal Mani. And you made a mention of that when you were talking about, $20 million went to the shareholders and $8+ million went to.
14 plus went to the
14.
community.
Yeah.
But yeah, they understand that. They understand they have jobs. They want more jobs, of course. All of them want jobs. Not all of them can have them because you have to train them and you have to make sure that they can. Some want to be drivers, but they don't know how to drive. They want to bring the cyanide to the mines, but they don't have the licenses to do that. So yes, you have to sit down, talk, and negotiate. And sometimes they just don't like you and they just close the road. And you can't get in for a few days. But as long as you have a shining path away from you, you can sit down because there's a people that, when there was shining path in the mine I was working at, and we had a couple of attacks there, the people from the communities and the towns next to the mines would come and live with us because we would protect them. Now they're out, but of course, hey, if you come along and you ask for something, but there comes, ask for more and I'll help you, then you come again. But we have to make sure that that dialogue stays there. The help is as much as possible. Of course, in the pandemic, we helped them substantially. We help them with whatever, when it's cold, when there's vaccines, when there's medical supplies. It's Peru, in that area, the only thing that exists 100 miles around you is the mine. So if you're not there, there's nothing. But suddenly you're there. So it's like, Daddy, give me everything. And we're not Daddy. And we cannot be Daddy to everybody. So we have to sit down in the same way that you do with your kids. I can give you this today, but let's sit down. You cannot give you everything. But that's an everyday conversation and negotiation. And it's been there for a while and will be there for a while.
Okay. Thank you. A question regarding, and these were questions that were sent in, by the way, from others. So I'm trying to weave them into his discussion here. You've been doing this for a number of years, 1911. It's a long time.
I haven't, but the company has.
I know,
I'm not that old, by the way.
Okay, I'm sorry. I thought you worked in a mine as a baby. No, okay, we won't go there. You've seen a lot of changes. What changes do you see in the future, in the coming years?
I've seen a lot of changes in environmental concerns, a lot of them, a lot of concerns in safety. More dialogue with communities, for sure, because they're starting to, communities 30 years ago were less educated or developed as they are now. So we can work more with them, and we will work more with them, but they ask for more, so, well, that will happen for sure. We're seeing different mines, like Aclara, but one thing that will happen next, I don't know, 20, 30 years is the easy deposits, the ones close to the surface, the ones that are easy to mine, are getting depleted. So you have to go way deep down. There's a mine that is being developed in the States called Constellation. It's called by RTZ, I think it's the owner, and it's 2,000 meters deep. That is changing the whole concept of mining. That has to be a lot of robots, because if you go down there, chances of you surviving are very little. Why? Because when you're down there, the pressure in the rock is so big that it's a little fraction of a rock it would just explode like a bullet and just will go through you. So going down there is very complicated, but that's what the ore is. And the world needs it. That's what I'm saying. Without copper, you cannot do a car. So you need the copper. You can recycle copper, yes, but we're building more cars than the recycle, so you need more copper. We're not there at the level where we're autosufficient. We're not there yet. So eventually those deposits will have to be developed. It will take time for it. We're not ready there yet. I mean, I saw your technology we're trying to develop, So I had to stop because we couldn't. But eventually those technologies will come and we'll be able to do more. But we have to wait for probably the oil industry to develop a little bit more because they've got more money than we do. And then we can, and they are exploring, we're exploring 2,000 meters, maybe 4,000, they're going 20,000. So we've got a leeway to maybe 20,000 feet, maybe 6,000, I'm not sure, but deeper than we are. So we have to understand what they are doing and what a pressure they have down there, trying to recognize what we can do. But that will happen. I don't know if I'm alive by then, but you will be.
Yes, exactly. So let me put an extension on that. This is like a wish, if you will. When might fully automated mining actually come into being? In almost every situation, it really is a big wish, if you will.
It is coming very fast. The cement plant, we built a new cement plant in the northern part of Peru. The old one has, I think, 300 workers. The northern one has 40 workers, out of which 15 are security. So it is happening. And on the mining side, it's happening. You can have trucks that are automated, but where we need to go is beyond that, because automation down there is complicated because, of course, Wi-Fi doesn't work when you're surrounded by stones, by rock. We need to get to artificial intelligence to make sure that it can recognize what rock it has in front of you, which is why we're working with Harvard has a system where through a phone they know which element is in front of them. So by recognizing with element, then you can actually drill and cut what you want. And that is what we're developing, trying to develop with Stanford. That's why we have those relations, and I hope we can do that with Tufts, of course, and try to find exactly what you want. But we're not there yet. That's complicated, still expensive. It will come. I think the basis of it, the understanding of it is there, but the technology is still unavailable at a price which makes sense, which is the same with the cement.
Right, you talked about the cement.
So we need to get to technologies that actually work. Copper is more expensive than before, but it hasn't reached that level where it is more expensive than the diamond. You need to drill it.
Exactly. I had a question regarding your cement. Oh, really, it's actually about something that you talked about, the circular economy aspect of your work. In other words, being able to basically completely encompass all the cost and all the work into one circular aspect. You're taking the mine, you're digging the soil, you're doing all that, and you come back at it and you're replanting at the end.
Yes.
Okay. When do you think that will be something that is not just common for you, but for the entire mining industry?
Why don't you ask the others? That would be difficult.
So
But no, I'm going to be very honest there. The deposit we have on this rare earth is very unique. And that's what we like about it. We're looking at other deposits similar to it in other parts, and we think we can do it similar things, but we're not sure yet. Other metals create acid water, and there's got to be a lot more to be worked upon before getting to that place. But don't forget that even in the gold, we are backfilling over 30% of what we take out. So we're already replenishing what we left. Some stays outside because, if we take something and you try to put it back in, it will take more space. So you can't put all of it back in. But just by sending some of it back in, you're already working towards that. We'll get there eventually. But I do believe that I think it's the same way the mining and the cement are working. I think a lot of other industries are doing the same. So we have to, all of us, get to a better place.
Let me ask this final question from me. It's one that actually got sent in, and I want to read it, so I'll make sure I get it right. It's from a graduate student here who's researching mining in Mexico. And they quote, "In my understanding, wholesale mining faced pushback from environmental activists and regional indigenous organizers concerning the exploration of a mining site in Guerrero, Mexico, for several years during the 2010s. You remember it well.
San Felipe, no?
No, it was a project that we had a long time ago in Mexico.
many years. Okay.
He's got a better answer than I do.
That's right.
He's the CEO, right?
He's the CEO,
He-
so
he
he's
knows.
given the answer.
Yeah, so now he can come and do the speech, right?
I get those news every once in a while, but they quote us, why are they still mentioning us? Yeah, but I'm happy to do
Okay.
that.
And the piece that I'm interested in is the fact that it was an indigenous community that we're concerned. I think every job you do is an indigenous community.
Sorry?
Every job that you have
Yeah.
to do, every mining site is an indigenous community. So I think you work with them on a regular basis. As you stated already, there are some cases that you can't work out a deal. You can't work out
Most of the
It's
times you
successful.
will, but sometimes you don't want to make a deal because you don't find enough ore to make it work it. Because you're asking for 100, maybe you're right, maybe you're wrong. If it's worth 1,000, I'll pay you 100. But if you ask for 100, it's worth 10. It's not worth the effort.
Okay.
So sometimes you just leave because if you don't find what you're looking for, you turn away. And that's what happened there.
excellent. Well, thank you for your time.
Thank
I'm
you.
going to turn this back over to Dean Lee for closing statements.
Wait, you want questions or no, from the audience?
Yeah, there's a question there.
Oh, we got questions from the audience. Should we let the audience actually have a question? Sure.
I think so.
We really don't have a lot of time, but I just want to make sure that one guy gets his question.
Can you give it to him? I can't walk past that. No puedo cruzar esto. Sorry.
Eduardo, it was an inspiring talk, but I thought I would ask the classic Tufts alumni question. So when you look back on your Tufts education, as you look back on it, what was the aspect of it that you most appreciate today, as opposed to what you appreciated then?
The fact of studying engineering and math, which I liked, and physics, of course, it was, I don't know what career they called it, but it was mechanical and physics, something like that. It's the logic that helped me understand the problem and find a solution. Because honestly, a lot of the formulas are way gone in my memory. But the concept of how to focus a problem is, and of course, the problem is communities, it's engineering, it's life. You deal with it in a special way, and that is what Tufts had taught me, way beyond anything else. And that, by the way, that also taught me just a little anecdote, which I think was pretty funny. I was in the mine one of those 2 years that I spent up there, and they asked me, I was having breakfast with all the engineers, they said, how many trucks can this locomotive carry, carriages? And I'm like, oh, I don't know, but that's typical, come on. That's what you like, right? Potence, weight, lubrication, water, all that. I mean, can you imagine the whole story? Okay. So then comes lunch. I said, I finished doing this. It can carry 9.5 tons. Every carriage has 2 tons, so you can carry 4. We know that. Like, how do you do it? I mean, it's a complicated deal. I mean, all the engineers are thinking about it. Come on. Lots of formula, lots of everything. Carried 1, carried 2, carried 3, carried 4. Didn't carry 5, carries 4. We knew that in 5 minutes. Logic behind. But at least my education was good. It did carry 4. That part was good.
Thank you, Kevin. Tough question. Eduardo, I want to thank you for your time in your lecture today and sharing your experiences.
Thank you.
Both during and after Tufts as well.
Thank you.
Thank you for this honest conversation about what industry does and what its contributions and importance is in our society today and probably well into the future. So thank you. So as a token of appreciation, I have some gifts for you. First, a swag, as we like to call it. And because this is Tufts, everything
Jumbo,
has
of
7
course.
elephants.
Of
So
course.
hopefully you can keep it in a place where you can, as you
Of
look
course.
at remind of Tufts, both here and in the past as well.
And this I'll wear. Not now.
Although the weather today is pretty good. Thank you.
Thank you very much. Thanks a lot.
Before I close, I want to also thank President Tony Monaco for being here today. And I thank you all for being and listening and engaging in this important conversation of the day. So with that, I'd like to close and invite you to join us for reception outside in the lobby.